Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ijlas Siddiqui bin Aidil. I came from DPU 3B. My matric number is 01 DPU 19F1045. Today I'm gonna to tell you about the introduction of heat exchanger. Heat exchangers can be described as the included all devices that are designed for exchanging heat. Only heat exchangers that are meant to exchange heat between two parts are taken into account. These fluids can be gases as well as liquids. It is still difficult to have an overview, and a classification needs to be made. It is possible to classify heat exchangers in a number of ways. A heat exchanger is a system used to transfer heat between two or more fluids. Heat exchangers are used in both cooling and heating processes. The fluids may be separated by a solid wall to prevent mixing, or they may be in direct contact. The sources of heat exchanger is from the sun and the earth's interior. There are three mechanisms for heat transfer, which is conduction, convection, and radiation. Next, I'm going to type of heat exchangers. Point number one is plate heat exchangers. A plate heat exchanger is a type of heat exchanger that uses metal plates to transfer heat between two fluids. This has a major advantage over a conventional heat exchanger in that the fluids are exposed to a much larger surface area because the fluids are spread out over the plates. These facilities good and very fast heat transfer to increase temperature change. Second point, second point is shell and tube bundle. This heat exchanger system consists of two sets of water tubes inside a condenser shell. Overheated gas enters through the shell where heat transferred to the water takes place through a small tube. Next, I'm going to pass to Muhammad Fitri to continue the type of heat exchangers.
My name is Muhammad Fitri bin Arsudi. My matric number is 01 DPU 19 F1055. I can talk about type of heat exchanger. Rotary rotary heat exchanger. The thermal wheel, also known as a rotary heat exchanger or rotary air-to-air enthalpy wheel or heat recovery wheel is a type of energy recovery heat exchanger positioned with the supply and exhaust stream of an air handling system or in the exhaust gas of an industry process in order to recover the heat energy. Other variants include enthalpy wheel and recycling wheel. A cooling specific thermal wheel is sometimes referred to as a Koto wheel. Next, round a round coil heat exchanger. This system pump to dry air to liquid to pass through the system. There are many small coils installed in series operational conditions for maximum heat transfer use. This system is suitable for all seasons. This is because the outside air is hotter in the exhaust air. The exhaust air will cool the outside air, and if the outside air is cooler using the exhaust air, The previous exhaust air hit the outside air. Therefore, the system is more and more energy efficient. Heat pump. A heat pump system is a device that transfers heat energy from a heat source called a thermal resource. The heat pump system moves the heat energy in the opposite direction from the spontaneous heat transfer by absorbing heat from the cool chamber and reducing it to a warmer place. Last, heat jacket. The water jacket system is stored on the side of the refrigerating machine or gas turbine to absorb all the heat generated. Hot temperature can be used to produce steam and also used to heat water or fuel oil.
Next, I will continue the next other presentation. My name is Muhammad Edi Syed bin Yusof. My budget number is 101 DPU 19F 1049. The question is a manufacturer to design heat exchanger in which the specification takes some steam at 4 bar to get heat secondary water from 15 degrees Celsius to 70 degrees Celsius. It is assumed that 1 liter of water has a mass of 1 kilogram. Mass flow rate equal to 1.3 liter times 1 kilogram equal to 1.3 kilogram per second. The manufacturer used to heat transfer coefficient U for the heat exchanger of uh, of 2500 watt to take the specific heat of the water as 4.14 kilojoule per four thousand one hundred forty 400 4140 joule per kilogram degree Celsius. At 4 bar gram, the saturation temperature is 152 degrees Celsius and heat exchanger is 2108.1 kilojoule per kilogram. Equal calculate the required system flow at the design condition. To find answer for the question A, we must use the formula to find heat flow rate. The formula is mass times specific heat times temperature. Answer we will get 296.01 kilojoule per second. To find question B, the corresponding system flow rate formula is kilowatt times 3600 kilogram per kilogram divide 2108.1. The answer we will get 505.5 kilogram per hour. And last question, minimum heating area to meet the required. The formula we use is final temperature minus initial temperature divide ln steam temperature minus initial temperature divide steam temperature minus final temperature. The answer is 115 degrees Celsius. Thank you.